Hey everybody, this is Kite Altair here, and in this video I'm going to be showing you guys my 90% completed Arthropod HVAC system. So this took quite a while for me to actually be able to shoot due to the fact that doing the coding for all of this, testing it and fine-tuning it was kind of a pain in the ass, but in the end I finally got it to what you see here. So as seen in the previous video, I have my 8-channel 5-volt JB Tech relay. I have my DHT22 sensor, which can tell the temperature, the humidity, and the heat index. For most of those, except the heat index, it'll be in Celsius as well as Fahrenheit. I currently have a white LED that is flashing every few seconds, a blue LED that is currently lit, a red and a green LED, as well as a active buzzer, 5-volt active buzzer, and of course the Elegoo microcontroller. So how this works is the Elegoo takes the reading from the DHT22 module. Depending on the code that I upload, the temperature ranges will determine what LED is lit and what happens. So in this instance that you currently see, the blue LED is lit, meaning that it is too cold. The white LED is currently it's flashing every few seconds, and that lets me know that the DHT22 is currently working and that the code is executing as it should be. The relay that you see, the one LED that is lit red, that tells me that because it is too cold, the Elegoo is going to activate that relay, which in my code example represents the heat lamp, which you can see here. This is the actual heat lamp I'm going to be using, activating. And by it activating, it'll increase the temperature. And by doing that, the DHT sensor will relay to the Elegoo a temperature change. If it's within certain values, that blue LED will turn off, and either the green or the red LED will shine thusly. And certain actions will happen based upon that. So I'm going to connect the ground to my buzzer, and you will see what happens when it is too cold. All right, we disconnected ground from the 5-volt buzzer. So that is what's going to happen anytime it gets too cold. When it gets too hot, there's a different tone, and I have a special little piece of code that I inserted in there to let me know what to do when the data signal from the DHT22 is not being read by the Elegoo. So what we're going to do in this is get a handy dandy Ace, shameless plugging, but I'm not sponsored by them. We're going to get this Ace heat gun, and we're going to heat up the DHT22 sensor, and you guys will see what happens when it gets too hot. So don't mind the volume, as I'm going to go ahead and connect this buzzer. Now note the sound. It's a long pulse. So now that we have the heat gun hooked up, turn it on, heat up the DHT22 sensor, and watch the magic. That should be enough. It takes a reading every 3 seconds. So bam, there we go. Now we have the red LED, and you can tell the tone is different. It's a lot shorter. Let me turn this off so you can see a little better. All right, so now we're gonna go ahead and disconnect the ground from the 5-volt buzzer. So now with this red LED being lit, it also activated this relay. So what that does is, if this was actually hooked up fully, what it does is activate a fan and also activate a Peltier cooler. Now I don't have a Peltier cooler because I have to actually build the enclosure for it, which I will get into detail shortly. But this will be what the system will use in order to cool itself off from overheating. Now, since of course this is all to hold the arthropods, more specifically my ants, this will ensure that I can make whatever type of climate that I want to within each enclosure. So if I have a tropical species, I could actually go ahead and have the heat be on more often and ensure that the Peltier cooler is not activated for that specific unit. And I could also actually hook it up to a relay that is also connected to a pump, which will create a more humid condition as well as the heat. If it were a desert, I would reduce the water, increase the heat, and make sure that the Peltier cooler does not activate for that specific enclosure. So no matter what the condition is, I could simulate it just using temperature, the cooling, and I could also dictate the humidity. So I'm going to go ahead and show you guys this setup. Alrighty guys, so this is the full layout of the Arthropod HVAC system. So as you can already tell, this is going to be the DHT22, which is going to be in an enclosure that's going to have some netting over it, and that'll ensure that it can still take a reading, but none of the bugs can chew their way inside. These are going to be two mesh materials that are going to be cut into the plexiglass, and it's actually going to have plexiglass on one side, so all this side will be plexiglass. This side will actually be an aluminum sheet, and inside that aluminum sheet will be two holes cut. One will let the heat in, one will have a fan that is exhaust, and it's also going to have a hole cut into it that'll let the cold air in from the Peltier module. Now here you can see in the DHT22 enclosure that there's actually a tube. So these wires, the VCC, the ground, and the signal wire are actually going to be in a tube, and that's going to route out into the actual enclosure itself where the ants can access, which is why it's all in a tube so they can't bite through it, and then it's going to leave the enclosure. And this is going to go to the Elegoo, which is going to be connected to the side of it via a project box, and it's going to have status lights at the top, at least in this iteration. I might change where I have them, the placement, but overall that's where it's going to be. Above I'm going to have a heat lamp that's going to be connected, so if the heat needs to be turned on, it'll radiate in. That's why it has a mesh, so it'll allow that heat to fully penetrate the enclosure. Now this tube that has the cold air, it actually goes to the Peltier module, and what that means is that if we go over here to the Peltier module, this will go to these tubes that you see here, will go to all the other enclosures, so not just this one here. I'm going to have to make an enclosure for it, and I have to make sure that it's sealed. And the air pump will be on top of it. That's going to pump air in, and since the air inside is going to be cold, there's no other way for the air to go than through those tubes. So the DHT module is going to be able to sense what the temperature is and adjust it accordingly. I was thinking about making it more individualized. At this point, I still need to do more testing, but either or, however, if I decide to have fans, put an enclosure and then have fans that blow this air in, or if I just have it all pressurized and then the DHT22 takes care of the heating, this is the overall layout. So the only thing that would really change as far as I can see is the Elegoo module, where its placement and the status lights will be. And that's really about it, and what I'm going to do about the Peltier module as far as delivering that cold air. So we're going to go ahead and switch back to the Elegoo module so I can show you two more things. Alrighty guys, so we are back to our Elegoo. So what this is also going to do, when you reset this, it actually does a power on self-test so that you can see that every single piece, every single component is running. We're currently green right now, so when I plug this buzzer in, nothing happens. But you can see the status light still going off, which means that the DHT is sending the signal to the Elegoo. But the white light is not going to be the only thing we use to see if the Elegoo is receiving data from the DHT22. What I decided to do is if there is some break in the data, there actually going to be another alarm that goes off so that you are alerted. So you guys remember how it sounded when we had the cold activate, when we had the hot activate, and this is going to be what goes off when we have no signal from the DHT22. So what is actually happening is it senses that this pin has been removed, and it's still going to try and take the reading, the DHT22. That's why you see that pause after it does those two beeps. So as it continues going, it senses there's nothing, activates it, then it runs through the code. It waits that delay, nothing's going on. So that's what's constantly happening. So it's just cycling through there. And then when you plug it back in, we are at pin 2, 0, 1, 2. Now we're fine. So that's how I know. Also, when I unplug it again, when it switches back, you guys should notice that the white light is not going off at all. It's just the red light and the buzzer. So let's plug you back in. There we go. So that's how you can tell if it's working or not, is via that. Another thing that's going to happen, every time you power it on, like I said before, it does a power on self-test. So let's press the big red button and reset it, and you guys can see how it works. So it's testing each LED, the relays, and then the buzzer, and then it starts taking that reading. So that is the entire project. This is how it's supposed to look when it is finished, but here is the idea. So the next step is to go ahead and get the relays connected to the different modules, such as the Peltier module. I need to get some fans, as well as getting some little breadboards, and I can put all of this on a prototype board. I can go ahead and get everything soldered up, and from there we'll be done, and I can go ahead and do my first test by having a captured colony. So that is correct. We are finally going to get a captured colony. Oh, and we are blue. And we're green. So the thing with this, let me unplug it. Since that happened, let me tell you this. So when it's taking the reading, it's taking it in Celsius. So if you want to go ahead and change the Celsius to Fahrenheit, you actually have to multiply it by 1.8 and then take that answer, whatever the number is, times 1.8, add 32, and that'll give you Fahrenheit. Now the thing is when I coded it, it's actually coded so that when you change the Celsius to the Fahrenheit, and it's in a very small range. The difference between it turning on and it turning off, going from the blue LED to the green LED, is a 0.1 degree difference. So as you can tell, this is very sensitive to DHT22. It actually is better than the DHT11 because its margin of error is a lot smaller, and it can take a lot wider temperature range. So that's why I use it. In the next iteration, we still have a few components that I need to buy, but it is very exciting to see that this is coming together. This is about 95% done. All I have to do is transfer this to a prototype board. Once I transfer it to a prototype board, I need to check some extra timers that are going to be connected to it, and we'll be just about done. So this is the video. Thank you guys for watching. I hope you guys like, subscribe, definitely share with your friends. I really do appreciate you guys being with me throughout this whole point. And we're still not there yet. And even when we get to the goal, we still have a long ways to go as far as trying out this Arduino. So I'd like to thank you guys for watching my video. I hope you guys have a very blessed weekend, and I will see you guys in the next video. Bye.